Hello everyone, sorry for the delay there. Had a little bit of a technical issue, but let's begin. Hopefully you can see my screen now. And it should say session 16, reciprocal and rational functions. So welcome to this session. We're almost at the end of our boot camp. Only 2 more sessions to go after this. If you are new here, I'm Ashley from Miss IB Maths, and I'm an IB examiner, tutor, and teacher, and I'm working in collaboration with Exam Dojo for these boot camp sessions. All of them they've been recorded and are on a playlist. If you want to go back and check any, please feel free to do that. And to start off with, a little warm-up question. We're doing reciprocal functions. So if you can answer in the chat, what is the reciprocal of these 3 numbers? 2/3, -5, and 3 3/4. Just to get your maths brains on if you weren't studying maths already. What is the reciprocal? Let's get the chat on here so I can see. Also, just let me know if you can not see my screen. Don't know if it's just loading. So let me just try that again because I can't see it on my iPad. Let's try that one more time. Could anyone confirm if you can see my screen? Maybe it's just a loading issue. How strange. So according to my screen, it's not loading at all. So I'm not sure if anyone else can see it. Could anyone message in the chat, please, if you can see it? Yes. Okay, great. That's good. Thank you. I think then my iPad, it's usually connected up, but strange, not working. Okay. Thank you very much for answering. Just check my Wi-Fi connection. And I'm on the right one. Oh, well. Okay. Never mind. Let's begin. I'll just have to go back and check every now and then that it's if you have any messages. So if I take a little bit of time to answer them, then let me know. All right. So reciprocal. We want for 2/3, the reciprocal is just when we flip it on its head. So for this one, it would be 3/2. For b, -5, the reciprocal is -1/5. Note that I'm saying reciprocal and not negative reciprocal. So when you're doing tangents and normals, that's the negative reciprocal. So then you're going to go from a positive to a negative or a negative to a positive. But here it's just reciprocal. So we just flip it on its head. 3 3/4, we can't just flip the fraction. We have got to turn it into an improper fraction first. So 3 times 4 is 12 plus 3 is 15 over 4, and then we can flip it. So 4/15. That is our reciprocal. So that's what we're going to be looking at with the reciprocal function. So the reciprocal function is the reciprocal of x. So if you take the function y equals x and you turn it around, you get the function 1/x. That's why it's called reciprocal, because we've just flipped the function of x. And now we can no longer have x equals 0 because that can't happen when it's in our denominator. So they'll always say x does not equal 0. And that part, these reciprocal functions, because we can't have a certain value, give us this shape where there are gaps in the middle. So because x is not going to ever be equal to 0, that also means that the y value will also not be equal to 0. And these two things give us our asymptotes. So while we cannot have any function, any values of x being 0 or y being 0, that then gives us our asymptotes. So we have for our asymptotes, those are the dotted lines that our function never crosses over. Our x asymptote, or a vertical asymptote, is x equals 0, and our horizontal asymptote is y equals 0. So we're saying two things here. Here we say x does not equal 0, and here we're saying x equals 0. Well, this is for our domain and range. So the domain is that x is not 0, and the range is that y is not equal to 0. And whatever our domain and range are not, is what our asymptotes are. So these two are always very closely linked. Domain and range, what we can't have, but what our asymptotes are. So when we've performed no transformations on this function, then it's just the line y equals 0 and x equals 0. And we have these two branches, one in each quadrant. So when it's positive, it looks like this. And if we had to have, let's say, g of x equals negative 1 over x, then they'd be in these quadrants. If that x had a negative, they would be in these two quadrants. So those are reciprocal functions, and we can do different transformations to our reciprocal function that can maybe move it a bit to the left or move it up or down, and we're going to have a look at that. So a couple of things that are important to note and that you are expected to know is that it's a self-inverse function. So the reciprocal function is a self-inverse, and you can check that out. We also have this property that if you have the function within itself of a composite function, f of x within f of x, you get x. So sometimes they can say, prove that the inverse function is equal to the original function, and you can use this property. That property shows that it is a self-inverse function. This property is useful for proving many self-inverse functions. So you could either find the inverse function and then you find or you have the original function and you show that they're equal, or you can use this. So let's try that. Let's put, let's say we have f of x equals 1 over x. And now I'm going to put that function, we can say, well, f of x, if I put it inside itself, well, wherever there's an x, that means I have to put the function inside. So I'll put a bracket because that's where the x needs to go. So 1 over x is, there we go, inside itself. And that just means 1 divided by 1 over x. KFC, keep flip change. That's the same as saying 1 times x over 1. That's how we can do division easily. And that's just x over 1, which is just x. And there we go. You can see if you have the function inside itself, you just get x. So this can be a very useful property to show that a function is self-inverse. And just in case I didn't say it before, reciprocal and rational functions are not necessarily a topic of AISL, but you will still get rational functions that you'll have to do things with, like domain and range. So this is still relevant for you, although you won't have to know how to graph them yourself. But there's still a few things that are relevant, such as the domain and range of rational functions, just understanding that. And there are a few other things that are still useful for AISL to know, but you just won't have to graph them yourselves because you'll just put it on your calculator and then you'll be able to copy that graph. So it's not an exact function topic. All right. Then rational functions. So this is a reciprocal function, but, it's a rational function that has a linear expression in the top and a linear expression in the bottom. So you can see here, if I zoom in, ax plus b over cx plus d. I'm just going to check the chat if there's anything that anyone is saying. No. So linear on top and linear on the bottom. So a reciprocal function is also a rational function. So it's in the family of rational functions, but these are the two that will get the f of x equals 1 over x or 2 over x or 100 over x with some transformations. Those are all our reciprocal ones. And these are the rational ones. So from these, we can find different things. So they also look exactly the same. The shape is exactly the same as a reciprocal function. They also have x and y asymptotes. And how we get those x and y asymptotes is by little tricks. And I'm not going to explain the full proofs for these. I'm just going to go straight into the shortcuts because at this point, I think we just want the shortcuts, not necessarily the understanding. So I'm just going to skip ahead the proof of these and go straight into it. So let's say we have a function f of x is 2x minus 3 over x plus 1. That's going to have a vertical asymptote, and that vertical asymptote is always an equation, x equals. And the horizontal asymptote is always an equation, y equals. So when they say give the equation of the vertical asymptote, please do not just write down like 2. You will not get a mark for that. You have to write x equals 2 and y equals 5, whatever it is, because it must be an equation. Otherwise, you're just writing down a number. So for our x, our vertical asymptote, we have to think what value of x can we not have in the denominator here? What will make it 0? That's to do with domain. We cannot have 0 in the denominator. So if x is 0, that's 0 plus 1, which is 1. That's fine. But if I have x as minus 1, that's minus 1 plus 1, then that's a problem. So whatever I cannot have there becomes my vertical asymptote. So it's minus 1, because we can't have minus 1 there. It makes everything fall apart. So my asymptote is x equals 1, and my domain, just write that next to it so we can really see, is x does not equal minus 1. Remember, they're linked. And we say x is an element of real numbers. We just always say that, that we're in the real world and no complex numbers. And then for our horizontal asymptote, we have a little trick that we take the coefficients of the x's. So here there's a coefficient of 1, it's just x, and here it was 2. So 2 over 1 gives us 2. 2 divided by 1 is just 2. So the horizontal asymptote is at y equals 2. So that means our range is y does not equal 2. Y is an element of real numbers. So these two very closely linked. So here we can see our vertical asymptote at minus 1 and our horizontal asymptote at y equals 2. And don't forget that vertical is x, horizontal is y, and you have to know which way around that is. So make some kind of rule for yourself that you remember that. Was there anything else I wanted to say? When you're taking the coefficients of the x, make sure that you have put it in that order, because sometimes the question may look like, let me put it here. We might have y equals 2 minus 3x over x plus, let's make it 6x plus 5. So a lot of students I see taking the coefficients of whatever is in the front and saying, oh, it's 2 over x, but that's not the coefficient of x there. That's the coefficient of x. So when they want coefficient of x, we want these guys. Whoop. So it's actually minus 3 over 6. Don't forget the minus as well. It's the coefficients of the x, not just whatever is in front. And that simplifies to minus a half. So watch out for that. Checking again, any questions? No. All right, so there we go. Let's try a full example of this. So we need to find the intercept, the asymptotes, the domain and range of the function below, and then graph it. So a very common question, they'll ask you to do all of these and then finally graph it. And it's actually a lovely, simple question that can often get you a lot of marks, so don't be scared of it. Remember that asymptotes and domain and range are very closely linked. So once you found the asymptotes, you've actually found domain and range. So let's start with our intercepts. So intercepts are when x equals 0 and y equals 0. So let's do when x equals 0. This is going to be our y-intercept when x equals 0. So let's just substitute for x equals 0. So we have f of 0. Well, 2 is times 0 minus 3. That's just 0 plus 1, which gives us, that's just 0. So minus 3 over 1, which is minus 3. Okay, so we have an intercept of minus 3 at y equals minus 3. So let's write that as a coordinate. Always helps us to plot it later on. That was our x. I'm just going to make that a little smaller because I'm taking a lot of space here. Okay. Then when y equals 0, maybe I can zoom in. Okay, when y equals 0, then I'm going to have 0 equals 2x minus 3 because now my y part was 0. I can multiply it with this x plus 1 on the other side to get rid of the denominator, and it's just going to multiply by 0. So we're going to be left with 0 equals 2x minus 3. And now it's a much easier equation to solve. So that is 2x equals 3. So x equals 3 over 2, or 1.5. So that's a new coordinate. So we have, sorry, all my writing is all over the place. Don't do this in your exam. You should write always downwards logically, not across. So it confuses the examiner. So there we go. I'm going to just put those in boxes so that we know for later when we're graphing. That is an intercept, and that is an intercept. Our x and y intercepts. Sometimes you don't even get 2. Sometimes you just don't, you get 1. Draw 1 intercept or no intercept as well. I've just seen a message come through that the lesson hasn't started for anyone. Yeah, I am not sure what's been happening. If you are, yeah, it says waiting. So this is very strange. Sorry, let me try and figure this out. Could anyone confirm that they are currently watching this live? Because I have one chat on this side that says someone could see my screen, and then on this one it says that the lesson hasn't started. 2 streams upcoming before. Oh dear, did I click on the wrong stream? I may have clicked on the wrong stream. Oh no. That is unfortunate. And I am not sure how to best solve this. I think the best thing that I'm going to do is potentially start this again on the other stream and delete the stream. So the one person who I think is here, is that okay? Would you mind that? I'm so sorry for that. I think I might need to start it on the other one because there are people waiting. Is that okay? Amazing. Thank you so much. I will stop this one and go on the other one. Thank you, and sorry for wasting your time. See you in the other one.